Okay, so for this screencast, we are trying to determine how far horizontally a solid disk, a solid sphere, and a hollow disk and a hollow sphere would travel after going down this ramp and then flying off the edge of the table. We want to find how far D each one of those four things would go. And we also want to find how much farther or shorter changing the mass or the radius of the object, of all four objects, that it would go. First we start out with our velocity final of x, which is the speed of the object in the x direction right here at the end of the ramp, which we determined in class the other day to be that, so I skipped doing that. It's also in the book. So now what we want to do is solve for delta t, which is right here, which is the amount of time that it takes for the object to go vertically from the table to the ground. We want to find how much time it takes for it to do that. So to do that, we use one of the kinematic equations for motion, which is right here. These two are both equal to 0 in this case, so we get t squared equals 2h2, this is h2 and this is h1, 2h2 over g, then we get t equals 2h2 over g to the 1/2. Now since velocity times a time equals a distance, this times this should give us our distance, that formula that each object will go, like that, and then we end up with that right there. D equals that. Therefore, looking at this equation, you can see that changing the mass or radius of any given rolling object will not change the amount of distance that it will go in this situation, since the moment of inertia of any object is something mr squared, so the masses and the radius will always cancel. So the mass or the radius will not affect any object. So determining which of the four here will go the farthest, all we need to do is plug in the moment of inertia into the equation that we just found. And since I just determined that changing the mass or the radius of the object won't change anything, I haven't solved for those, since we know it won't change anything. So for the hollow disk, moment of inertia is mr squared. Plug it in there, the mr squareds cancel, you end up with 4h2 over 1 plus 1 to the 1/2, which is that. Solid disk, plug in moment of inertia, the mr squareds cancel, you end up with that. For distance, hollow sphere, moment of inertia right there, plug it in, you get 1 plus 2/3 on the bottom, you end up with that. Solid sphere, moment of inertia right there, mr squareds cancel, you end up with that. And one thing I failed to mention is that all the masses and the radiuses and both heights on all of these are the same. I probably should have mentioned that. So since 20 over 7 is greater than 8/3, is greater than 12/5, which is greater than 2, the objects ranked in order of distance from greatest to least would be solid sphere, solid disk, hollow sphere, and then hollow disk.